Welcome to our class 2, or BID class 2, where we're going to look at the measures of central tendency. The measures of central tendency, we want to understand how to calculate the measures of central tendency for raw data, which includes the mean, the mode, the median, and the weighted mean where possible. We're also going to find what are called quartiles: the first, the second, and the third quartile. So we'll start with what we call the average, which is also the mean. So we have a table of enrolled students at Unilas. So the number of enrolled students in different statistics courses. So 18, 22, and we are being asked to calculate the mean or the average number of students per class. So we simply add the first observation, second, until the last observation, which is the fifth observation, divided by n. So this is called mu. So mu stands for population average. X bar stands for the sample mean. When they ask you to say the class has 100 students, of these 100 students, grades of 10 students were as follows. I give you the grades of it. 10 students in that class of 100. So the average for those 10, you add 1 up to 10 observations divided by 10. That one is called the sample mean. But the whole 100 students in that class are called the population. So the formula is the same, but I just want you to differentiate that as what we call sample mean and population mean. So population simply represents all the available data. In statistics, these are the available observations that are there, whereas the sample is a subset of the whole population. So this is called a population mean. So we're given the values that we have here. We're asked to calculate the mean number of students. So you can see the observations here of 18, 18, 22, 22, 25, 25, 26, 26. But one variable here has increased. Instead of 15, we've increased it by what? We've increased it by 60. So we now have, instead of 106, the total, it will be 166 divided by 5. So I'm just trying to show the relationship that the average increases as you increase the sum of the totals. Summation of X simply represents the number of what? Individual elements that we have in there. Are we together so far? At that point, are we together?
Yes.
Yes, we are.
All right, so if that is clear, so I'm starting with what you think you know, what you do not know. All right, so the mean, we are told that there's a random sample of 7, which is collected from the customers in a grocery store. So this is just a random sample of 7. So the mean is going to be called X bar because that is just a sample of the number of customers that you have. So you add them, this plus that, plus that, plus that, plus that, divided by what? 7, which is the 3.9. So this is called sample mean, which is X bar. So you need to know the distinction between the two. All right, so basically about the mean, is about the average. Now, I'll just make it a little bit complex for the mean, where we're going to calculate the mean of a data sample where some of the information has been removed. Let's look at this question here. This is a test or an exam type of a question. We're told that below we have a list of what? Ages for players in a basketball team. These ones are 10. But we are told that at one point the oldest player was released. All right. And a new player was put in. After that old player was released, the average changed. I repeat. Below we have a table of what? We have a table of basketball team members. Now these basketball team members, we are told that it was discovered that one of them was too old, was above age, so they had removed the oldest. And when they removed the oldest, the mean reduced by 1 year. The question is find the age of the new player. This is about 5 marks, a tough question, so you need to think through now. All right, to start with, mean is given by what? Summation of x over what? Over n. Are we agreeing there? So we're going to identify the total. The summation of x in here, when you add this plus that, we're going to get 208. Then how many players are they? There are 10. So 280 divided by 10, we get 28. Are we together so far? You get your 2 marks for that.
Yes.
This question is tricky. So it said, when we dropped off the oldest, the mean reduced by what? So the mean one that we've calculated is 28, and meaning the mean 2 should drop by 1. We'll go to mean 2 to be 20 what? 27. Are we together at that point?
Yes.
Then also we need to identify who was the oldest in here. Oldest here. So we need to identify the oldest age in here. So which one is our oldest age in here?
36.
86, correct. 36. So when we remove this one, so one thing you need to understand from this is that the mean is given by summation of what? X divided by n. So when you cross multiply, the number times the mean will give us a sum total of x. All right, this we are agreeing. Now for the first instance, we calculated, we had 280 was the total, and the 10 was the number of people, and it gave us a mean of what? A mean of 28. Remember this, right? Now, this one, the sample was what? For the next one, the mean was 27. All right, we know that it reduced by 1. The second mean was 27. How? Because we know that it was reduced by 1, but we don't know the total. So here, the n, even if we replace the orders, there's still going to be 10 people. So 10 people, all right? And the mean 2 is what? 27. The second mean is 27, right? So we need to find the sum total of the ages for the second group. So meaning the total here will be 270. The sum for the first group was what? 208. Are we together so far? The sum for the first group is 280, which is this one here, the group 1. 208, but we don't know the sum for the second group. All we know is that the mean reduced by 1. So here where there's mean for group 2, we put 27 because we know it reduced by 1 there. So 27 times 10, obviously the total should have been 270. All right. Now, if group 1 was 280, group 2 was giving us 270. So meaning the difference between the difference after we remove the oldest one, the difference in age should have been what? 280 minus what? 270. Meaning
10.
the 10 is the difference. That's not the age of the guy, but the difference. So we identified that the oldest guy here was what? 36 years. So meaning if there's a difference of 10 years between the young guy who was put and the oldest who was removed. So what do you think was the age of the young guy? Because the difference, we're already told the difference is what? Is 10. So young guy should have been how old? The young guy should have been 26 years old. All right. That is the implication. Please beware of such questions in lives. We all know that questions come from this. So when you apply 27 times 10, you get 270. Now 270 we subtract from 280. The difference between the replacement and the old guy was 10 years. So since we know that the oldest guy was 26 years old, meaning for us to have a 10-year difference, the young guy should be 36 less 10. So meaning this young guy should have been 26 years old. This is where you get the 5 marks. So it looks easy, but it's not an easy question. Are we together?
Yes, we am.
All right. If there are no questions, we can proceed. Okay, so
My question could be,
mhm.
not on the actual question. I've understood the way you've done it. But then I'm just looking at an exam whereby it seems that it has got different stages. What if you miss one? Okay, you still do the actual the figures, you put them there, and then maybe how you were writing, I think on this left side, there's like H, C, and the sum of N. What if you don't put it like correctly and then you still get the actual answer properly?
Hey, it's okay. There's no particular procedure to say you need to use it like this. Okay, so it's okay. So let's go to, this is the exam paper that was written just last year. Okay, let's look at one question together on the means. All right, so let's look at question number B and question number C. So usually these ones come in the test from the exam. It comes part of the test. So you expect this question. So now we're told in here to say the average dividend declared by a group of 10 chemical engineers was 18%. All right. And then later it was discovered that one figure 12 was misread as 22. Find the correct average. Let's go through it again. We are told that we have how many? 10 chemical engineers. And the average was what? For these 10, it was 18%. So put 18. Then it was discovered later on that there was one figure in these 10, which was read as what? 12. Supposed to be 12, but it was misread as 22. So this was an overstatement. All right, they overstated by how much? By 10. So find the correct average. These are on the averages. So let's put our data together. So N was what? 10. The average for this 10 was what? 18%. Then there was what? A figure, a value of X, which was 12, but incorrectly written as what? As 22. So, meaning there was a difference of what? 10. Okay, we wrote 12. I wrote 22 instead of 12. So did we add or we subtracted from ourselves? Did we overstate or understate? So we know that mean is equal to what? Summation of X over N. So our mean here is 18. Our summation of X we don't know. Our N here is what? 10. So we cross multiply. Summation of X is equal to 10 times 18, which is equal to 18. Now to correct this mean, okay, correct this mean. So we have the original summation of X, which is 18. Then we have a difference of what? 10. So instead of writing 12, we wrote 22. So we added a 10. So meaning to correct it, we need to subtract. So our correct summation of X should have been what? 18 minus what? 180 minus 10. So we're supposed to write 170. So mean, what is the correct mean therefore? The correct mean will be summation of X over N. So to be 170 over 10. So the correct mean there will be 17. 3 marks for that.
This one, I'm so lost.
Yeah, followed.
I'm so lost to this one.
Yeah, so
Okay, I want to understand why do we do this and why do we do that? Because I think if I fail to understand that, then I'll be confused in exam.
let's go back again here. The average dividend declared by a group of 10 is 18. So meaning the mean for 10 people is 18. But when we're auditing this mean 18, we discovered that we got this 18 erroneously. Why? Because on these figures here, okay, on these figures here, maybe we had a number, maybe we had, these figures were 10. We had 4, we had 7, we had 8, we had 12, we had 15. There are 10 of them, maybe we had 20. When we divided these ones, we divided them by 10. The mean we found was 18. Now, for us to get a mean of 18, meaning the sum of these ones on top here, would have been what? 18 times 10. So all these here on top here, the total of them should have been what? 180. Because 180 divided by 10 will give you 18. Is that clear so far?
Yes.
Okay, if that is clear, after auditing, we discovered that there's a number 12 there. This 12 was not entered properly. Okay. In fact, there was a number, let me say this number was not 12. In fact, it was 22. Okay, to get 18. All right. When we add all these, we get 180 divided by 10, we get 18. So we discovered that this 22 that we entered here, in fact, we're supposed to write 12, not 8, not 22. So find the correct mean. So in short, what you're supposed to do is to make an alteration for us to write 22. Okay, instead of writing 12, meaning this 12, we overstated it by 10. We wrote 22 instead of writing 12. So meaning we gave ourselves 10 points. So to correct this, you subtract this 10 so that this 22 figure is read as 12. So it's like a correction we're making. Are we together so far?
Yes.
I repeat, these figures here, for us to get 18, are adding to what? 108. Now, this figure here is wrong. We've discovered that we made an error. Instead of putting 12, we put 22. So the only correction we need to do is, let's just subtract, because the difference between 12 and 22 is 10. So this total here, we subtract the 10 also, so that we correct this figure. When we subtract the 10 there, the total now becomes what? 170. All right. Then now they're asking what is actual correct mean. Just divide 10 into 170. We get what? 17. As simple as that. Is that now clear?
Yes.
Are we all following? So this is how you get the 3 marks. This was in the exam. This is how we get the 3 marks. Nosiku, are you following?
Let me just copy.
Yes, I am, Mr. Collins.
All right. So I saw this whole paper in the paid up group. Please access the solutions for the whole entire paper. But you're part and parcel of it. If not, I'll resend it. Make sure you're all in the paid up group. I'll not be sending videos in the speculative group anymore. Only those that are paid up, because this is yeah. So you're done copying. You can proceed on.
Okay. Yes.
All right.
I'm done. We can proceed.
So we can proceed now. I want to take my time so that you understand and see the errors that your friends were making in the previous exam so that you don't make them as well. All right, so let's go to this question, part C. The mean of 200 observations was what? 8. So people were now confusing which one is the mean between these two. Before I go on, the mean of 200 observations was 8. Which one is n and which one is x bar?
The N is the 200,
Good,
and then the X bar is 80.
exactly. So the mean for 200 observations was 80. Later on, it was found that 2 observations were misread as 92 and 8 instead of what? 90, 192 and 88. Which ones are correct and which ones are wrong from your English?
So the 8 is correct.
No.
So the 192 and the 88 are correct.
Good. Correct ones are these ones. And the wrong ones,
Yes,
these ones. Are we all agreeing?
yes.
Okay.
Yes.
A question. So how many observations were there? There were 200. So in this 200, the mean was what? 80. So there were figures, maybe 3 plus 4 plus the 2 wrong figures which were put there, which were 92 and 8. 92 plus 8 plus, I'm just putting arbitrary figure just for illustration's sake. These may not be the actual figures. I just want you to know. So we are told that these figures, all of them here, are 200 from here up to the end. So when we cross multiply this one times that one, we get what? 16,000. So we're told these figures here, all right? These figures you are seeing there, their mean was 80. Is that clear so far on the statement? The mean was 8. Now, we wrote two figures, 92 and 8, wrongly. Instead of writing 192 and what? 88. So this figure here, 192, it's supposed to be what? 192. All right. So this was supposed to be 192. And the other one was supposed to be 88. So this is supposed to be 192. This was supposed to be 88. So what does this mean? The difference here. 192, we understated by how much? By 100 here. So here we miss it by 100. And here we miss it by what? 8. So we entered a wrong figure below by 100. We entered a figure here below by 8. So these figures have to be added back to balance it up. They total up to 180. So you need to add the 180 here. It's the opposite. The other one, we over added. Here we under added. So 1,600 plus 180. So we're going to get what? We're going to get 16,180 divided by 200 to get the correct mean. What becomes the correct mean?
$80.9.
80.9. All right. So that is what's supposed to be 80.9. Do we follow what has just happened?
Yes, we do, but the question would be, why is it that the other one we under what, and then the other one
So
was
here,
added?
the correct figures were more, okay, than what we entered. So we add to make them more. Here, the correct figure was smaller than what we actually added. So we subtract. So let's make a rule. If what you actually entered is smaller than the correct figure, you add to adjust. If what you entered is more than the correct figure, you subtract. Is that easier?
Yes, it makes sense.
All right. Okay. So can we proceed now? We now go to our next question, part D. From the analysis, wages were being paid to employees in two services. All right, so we have our number of employees, the average, and the variance. All right. Now, before I proceed there, let me teach briefly. If you have samples like 2, 4, 4, 6, and 10, these are called values of x. When you square them, they are called x squared. Are we together? So let's add them here. This is called summation of x. This is called summation of x squared. So 10, 20, then we have 16. 1, 2, 3, 4, 5. Our n is 5. Okay, so we can square these ones. Here we're going to have what? 4, 16, 16, 36, and what? 100. Can somebody add for me there?
$172.
172. So let's find the mean. Who can help us find the mean? Summation of x over n. So 16 over 5. What do we get?
3.2.
3.2.
Do we all agree? 3.2. Then who can help us find the variance? Summation of x squared minus summation of x to the power 2 over n, everything over n minus 1. So if we substitute the figures there, we're going to have 172 minus 16 squared over 5, everything divided by 5 minus 1. Can somebody help calculate that? So you start from here. 16 squared divided by 5. So usually people make mistakes because of not using the laws of odd mass. So use the grade 1 way, the BID way. You don't overtrust your brain. It may end up misleading you. So what are you getting there? 16 times 16 divided by 5. You get what?
4. I'm getting 4.
Pardon?
Oh, okay. I finished the whole calculation. Sorry. Okay,
51.2.
16.
51.2.
Yes, 51.2 from 170 to what are you getting?
20.8.
120.8 and divided
Yes.
by 4.
30.2.
Good. So this is called our variance, 30.2. When you square root it, you call it a standard deviation. ST. So what is the square root of 30.2?
5.495.
So 5.495.
495.
Are we together so far?
Now we're behind. I think I'm where you left on the 6.2 square root.
Okay, are we together on 30.2, everyone?
Hello, hi Connie.
No, on the mean we're together, right?
Yes, I think I'm lagging behind on the 16 squared. I think after 16 squared, I was also trying to confirm my calculation.
So you can just do 16 times 16 divided by 5. 16 times 16 divided by 5 should give you 51.2. Then subtract 172 minus 51.2. You get 120.8. Then 120.8 divided by 4, which is coming from 5 minus 1, we get 30.2.
Okay, the way I calculated it, I think it's 16, like 16 to the power of 2. I think that's wrong.
It's okay. 16 to
I
the power
think it's also,
divided by 5 it should give you the same thing. There's a squared or to the power 2.
yes, I found 51.2.
Yes.
Then I subtracted with 172.
If you punch 172 minus 51.2, then directly divided by 4, it will give you a wrong
Now,
because it will first
okay.
from there. So you do equals. That's why we need to learn step by step. 172 minus 52, you do equals. When it gives you this, that's when you divide by 4.
I found the correct answer. Thank you.
All right. Then we find the coefficient of what? Variation. It's simply the standard deviation divided by the mean over times 100. So 5.495 divided by what? 3.2. What are you getting? And leave it there, or times 100 if you like, it's okay. What are you getting?
1.7 times 100. 171.
171?
Yes, I found 1.7 and then I multiplied by 100. So I found 171.7.
171.7%. Okay,
Yes.
so this is called the coefficient of variation. So if you're comparing two figures, the one with a higher coefficient of variation means it has more what? Variability. It is deviating. So standard deviation simply gives you a picture of how much you are deviating from the mean. The more we deviate from the mean, the more inaccurate we are. Okay, so standard deviation over mean gives you our coefficient of variation. So we go back to our test question exam. So we've been given the number of earners for company X and Y, the average earning, the variance. So the standard deviation is simply when we square root each of these ones here. What is our standard deviation for this one? 30. What is standard deviation for company Y? 40. All right.
Where are you getting those figures? Is it the same one that we calculated?
Now the square root gives you a standard deviation. If this is a variance, when you square root it, we get the standard deviation. We just square root this on the calculator to give you this and that. Okay, so we know that mean is equal to what? Summation of x over n. So meaning and cross multiply the n times the mean is the summation of x, which is giving us what? The total number. So if we multiply the sample size n times the mean, we get a total number. So let's get the number of earnings for each firm. So 550 times 5,000. What are we getting for company X? Because we want to know which organization pays a larger amount on a monthly basis. So to find the total amount, we multiply the mean times the number of earners. All right. So of the two, the one which will give you a bigger figure is the one that which pays more. The rationale here behind is sometimes your mean could be the mean earnings for a company, maybe could be 1,000 kwacha. The other one, the mean earnings is 500 kwacha. But you discover that the one which is paying mean of 500 is one that pays more money because it has more employees. So let's calculate now. Multiply this one times that one and multiply this one by that one so that we know which one pays more money.
Organizational.
What are you getting for organization X and Y?
Oh, I found 2.9, 2.925,
For Y you
and
found
00. For Y, I found 2.925. 2
right?
million 925.
2 comma
0.925,
9
92925.
925
Yes,
1 comma.
000.
Okay. Then this one
2.750, 2.750,
750.
3.0, 000.
So which one pays more money? Organization.
Why?
Correct. Then which organization has more variability in individual wages? So we find the coefficient of what? Variation, the CV. So CV is equal to what? The standard deviation divided by what? The mean. So let's calculate 30 divided by the mean is what? 550. 40 divided by 650. The one with a higher coefficient of variation, it has higher variability. It is more risky. So let's calculate. 30 divided by 550 times 100. What are we getting?
Hello?
Yes, please.
I found 5.45.
5.45%. We multiply by 100.
Yes, I did.
Then here,
6.15.
6.15. So which one has more variability?
Why?
So Y has more variability. Okay. So that is how you calculated it. So you get your 7 marks from that. Interesting, isn't it? Like people perish because of what? Lack of knowledge. So this one is an issue of principle. If you do not know, you cannot guess. All right, so if that is the case and we have all understood, we can proceed. So I've explained these figures. Now I want us to go to identifying the quartiles, the positions. Okay. So how to identify the median? So we have a table here that has 9 scores. How do we identify the median? So you arrange from the smallest to the biggest. So the smallest is 71 and the biggest is 96. So you rearrange them in ascending order like this. So they ask us now to find the median. Now the median is a 50th percentile. 50% is median. So you use the formula P over 100 times N. So the P is a percentage, 50th percentile. So, and how many are they? They are 9. So we're going to get 4.5. So whenever we get a 4.5, we round up always. Whether we're at 4.1, we round up. So the 5th number here is what we get. So the 5th number, 1, 2, 3, 4, 5, that is 85. So the 5th number in this case is 85. All right, so we're given this question here. The 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, find the median set. So same, the 50th percentile. So we get 4.5. We round up, which goes what? The 5th score. 1, 2, 3, 4, 5. So 85 is our 5th score. We always round up. All right. Now suppose we're at 11. Temperature, we rearrange the usual from the least to the greatest.
Sorry, Collins.
Yes,
Can you
please.
please come again on the formula for the median?
The formula of the median. Median is simply P over 100 times N. The P is a percentile. Median means 50%. So 50 over 100 times what? The number of elements we have. We have 9. If you want, you can simply say half of N in short. Some books will give you half of N. Median means half. So half of 9 is 4.5. For 4.5, you always round up. This is closest to the what? Number 5. So you count 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. So this is up. Suppose 11, median is 50th percentile or half. Half of what? 11 is 5.5. So 5.5 will round up. The nearest is what? The 6th number. 1, 2, 3, 4, 5, 6. So 69 is the 6th number. This is on the median. So sometimes you'll be given numbers like these ones here. They are 24. They're an even number. So whenever you have an even number, you get that number. For instance, if you have number 6, half of 6 is what? 3. If you get a whole number, like half of 6 is 3, you get the 3rd number, and the next number which follows is the 4th number. Then you average them, you divide by 2. So tell me, if your N was what? 24, what do you do with the median? What do you do? Half of what? 24 is what? 12. So what do you do when you find a 12? You add the next position as well, the 13th number. You divide by 2. meaning you find the mid-range. Then you divide their solutions. So here we're given the rankings of customer service for 24 clients. So these 24 clients, you can identify the highest value here, which is 96. And the smallest number in this whole scenario is what? 62. You add the smallest number and the highest number, you divide by 2. This is to determine the extreme data set. So you get 158 divided by 2, which is 79. So this is what we call our mid-range. The mid-range is a quick way to estimate the center of the data without having to add all the values for the mean. If you have a lot of values there, okay? So the mid-range is a quicker way to estimating the center without adding all the values or sorting them from the highest. So if you have many values, you can simply find your median by simply finding the highest number and the smallest number, add them and divide by what? By 2. The figure you get is almost close to the median. But to be precise, what is the mid-range here? The highest number here is 152, which is here. And the smallest number is 86. You add them and divide by 2, which is 119. Again, this is our mid-range. You can also do the same with integers. The highest number here will be 32. The lowest number is -10. So you add them, you get 22 over 2, which is 11. So this is our mid-range. I'm not interested in this so far. I want us to learn how to calculate.
Sorry, Collins, just a question on the negatives. We just have to write them the way they are, because I don't think, do they have the similar answer, just putting it like that?
Yeah, if they ask you to find the mid-range of the data set, you just get the highest value plus the lowest value, divide by 2. That is how we find the mid-range.
I mean on the negatives, because I've never
You
seen
write
it
them as they are, because
necessarily.
one here, a negative and a positive gives you a negative. So in short, we are subtracting 32 minus 10, which is 22. But if you have negative and a negative, these will add up. It will be 32 plus 10 divided by 2. But of course, since we're adding there, whenever the signs are different, you use a negative sign. Whenever the signs are the same, whether they're both negatives or they're both positives, we use a positive. But if they're different, it's always a negative that prevails.
Thank you.
All right, so we go back to the first question we had yesterday. Now we're going to look at some values we call the mode. We have the demand for hammers. So zeros, there are 4, 1s, there are 2, 2s are 7, 3s are 4, and 4s are 3 from this data set. So they're asking us to find the what? The mode. The mode is simply the highest frequency. So in this case, our highest frequency is not a 7, but the daily demand of 2. We're able to tell from here that our mode is 2 because it appears the most. So 2 is our mode. All right. We'll have this data set here. 1s are 1, 2s are 1, 3s are 1, 4s are 2, 3 and 5s are 3. So we have 2 renowned figures there. So 4 and 5 are our mode. So we call this a bimodal frequency where we have 2 modes. If they're more than 2, we call it a multimodal frequency. So it's a bimodal frequency. So values 4 and 5 will occur more than any other numbers. There are times where everything appears once. In this case, we'll say there's no mode at all. No value, no mode. Nothing supersedes the others. That is what we call the mode. So now let's get to describe this data. They're asking you to describe this data in any two different ways using central tendency. So I give you numbers in minutes. So I've taught you almost all the modes, all the various ways of central tendency. So we can find the mean. The mean is simply by adding everything. You divide it by the number of observations, which is 10. So when you add all these divided by 10, we get 12.7 minutes. So how do you describe this data? This data simply tells us that our mean, our average time, okay, is 12.7. So it gives us a mean sample data. Sometimes you can rearrange this data starting from the smallest, which is 5, to the biggest, which is 20. All right, then identify the median. How many are they? They are 10. So half of 10 is 5. Whenever we find a whole number, we get that number, the 5th position plus the 6th position, following divided by 2. So let's identify that. So 1, 2, 3, 4, 5, and 6. Then divide by 2. So 12 plus 15 divided by 2, we get 13.5. So this is called our median. So median. So in this case, we can describe this data by the mean, that it has a mean waiting time for customers of 12.7, and our median, okay, median average, which is 13.5. We can't use mode because there's no choice which is most frequent. So when the sample size is even, we usually add the next number to the whole number that we had. If we have 5, 5 plus 6 divided by 2. Then we have data here, and we are asked to choose the most appropriate measure of central tendency between the mean, the mode, and the median. So let's start. Firstly, we can rewrite this, arranging it from the smallest, which is 15, the highest, which is what? 96. So we rearrange this. So let's start with the median. How many are these? 1, 2, 3, 4, 5, 6, 7, 8. So half of 8 is what? 4. For the 4th position and the 5th position, you find a whole number, you get that. If it was 4.5, you round up, or 4.25, you also round up. 1, 2, 3, 4, and the 5th position, we add them up, we divide by 2. So 87 plus 90 divided by 2. So we get 88.5. All right. So 88.5. That is for the median. For the mean, how do we find the mean? How to find the mean? The mean score when we add everything divided by the n. So when you add 1, 2, 3, 4, 5, 6, 7, 8. So when you total up this divided by 8, what are we getting? 79.6. Then also the mode most frequent, which one is appearing the most here? There's nothing that is appearing the most. So here, our conclusion is that the mean exam score is 79.6. This one is lower than O, but the lowest score, so hardly the center of the data. So there's no mode for the data set. So the good central tendency is the median, which is giving us something higher. So you pick the one which is giving you a higher value. So compare 88.5 to 79.6. So you'd rather go for our median, which is giving us a higher measure of central tendency. Are there any questions at this point? So if there are no questions, I can proceed. Okay, so 7 minutes that are remaining. So we're going to look at the percentiles as well. So the 50th percentile is the median, but they may ask you to find any other percentile, like the 30th percentile, 25th percentile. So just use the same formula here. With this index that has been given, find the 30th percentile. So it's simply 30 over 100. And how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9. So we find 2.7 there. So whenever you have an integer, whether it's 2.1, you round up. So 2.7 is closest to 3. So 1, 2, 3. So our 30th percentile is what? 270, 257. So we may have another data set, which is here. They ask you to find the 65th percentile. As usual, you arrange them in order of ascending. Then 65 over 100 times 11, which is 7.15. You round up 7.15. The nearest is 8. So you count 8, 1, 2, 3, 4, 5, 6, 7, 8. This one is 2.21 million. So this is what we call the 65th percentile. The 40th percentile is 40 over 100 times what? How many are they? Count 1, 2, 3, 4, 5, up to down, so they're about 10. So 40 over 100 is 4. But this is an even number. So we add 4 plus the 5th value divided by 2. So the 4th and the 5th value, 1, 2, 3, 4, and 5. So when adding, we divide by 2, we get 908. So this is our 908. We add the 5th and the 6th, the midpoint of these ones. The story is simply the same. Are you getting me? Are we moving together on the percentiles?
Yes, sir.
All right. So whether they give you the 15th percentile, the story is simply the same. I don't want you to get confused. So one of these questions came in your tests. So we're given the blood pressure for 15 adults. Calculate the rank of, now this one where you are reading from inside. Now this one is tricky. So firstly, you rearrange, you're asking us to find the rank or the percentile of the value 126. So rearrange them in ascending order. So after rearranging them, you identify 126. Where's 126? It is here. So you count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So after identifying it, how many are they? Okay, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, when we count this 126, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's on position number 12. Okay, now how many figures are below these ones here? How many figures are there? From here, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to say, so the 11 values that are less than 126. So to calculate the percentile, we're going to say a number that are less than that value, which is 126, we add a 0.5 there. So 11 plus 0.5 over the total number of values times 100. So 11 plus 0.5 over 15 times 100. So we get 76.7%. That is our reading in terms of the percentile. So this is 76.7. I repeat, these figures here are 15. When you count 126, it is on position number 12. So you calculate the number of values before 126, they're 11. So you calculate 11 over the total number of values that we have here, which is what, 15 times 100. We get the percentage. So this is what we did here. Now this 11, we add a 0.5. So this 0.5 is just what some books do. Others, you can leave it out. Okay. So this step, you can get a full mark whether or not you add a 0.5. So this is the figure there, 76.75. Let's try this one here. Let's calculate the percentile for 20 left by 20 customers on the $10 tip. So we arrange this from the smallest to the highest. The $10 is where? Here. How many numbers are before the $10? 1, 2, 3. So we're going to say 3 plus 0.5. And how many tips were there? There were 20. So 3.5 times over 20 times 100, we get 17.5. This one purely, my people perished because of lack of knowledge. If you don't know, you can guess. All right.
My question. So the 0.5 I was about to say, is this thing coming from? It's just a formula that
Yes,
you have
just
put there.
yes, just yeah.
There's something that you said about the test. You said this question at the
Let me check it
beginning.
out. It was there in one of the exam or test. Okay. It was the textbook sorted as follows. Okay, this was a similar question here. Then 126, which one? It came like this, but they asked, okay, I'll look at the empirical rule, but it came to calculate how many the percentile for 126. So here you calculate from here, you count the number of, because these questions come. So this is the exam. I'll come up to the empirical rule later on, just after this. So all these, the same story is what holds. Just count the figures below. Now, this question came in the test. So we are told that with 2 exam scores, the table shows English and chemistry. So we are told that a particular student scored 88 in English and what? 76 in chemistry. Determine which score is relatively higher. So we're going to use the percentile. So for English, let's find the percentile for this 88. And for chemistry, let's find the percentile for 76. So 88, let's go to English. Where's 88? Is 88 there? How many figures are below 88? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we get 16 plus 0.5 over the 25 scores times 100. You get 66. That is your figure. Then for the other one, 76. Identify where the 76 is. It is here. Then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it will be 17 plus 0.5 over 20 times 100. So you get what? 87.5. So which one has a better performance? Is it chemistry or English? So you can tell here that the student performed better where? In chemistry exam relative to her classmates than in what? And in English, because here she had what? 87.5 as a percentile. Interesting, isn't it?
It is. And then when you look at the question, how would you know Because me as a lame person, how would you know that this is for the penta, we can use the pentas?
It's difficult to know if you have not gone through what I've taken you through. The other way, people would calculate a long cut, where you calculate all these, you find the what? The mean. You calculate here, you find the mean, the coefficient of variation, the percentages, you compare them. That one will take you even 3 pages to do that. But if you know this, you just use the rankings. Whenever you hear to which one has a relative higher, which score is relatively more, just know that we're dealing with percentiles.
I think
All right. Are we moving? Okay, so I can now proceed. So we go to using the weights, different weights. All right, so weights are important. So we can use this question here. We have Maggie who wrote her exams based on 3 combinations: the final exam score, the project score, and the homework score. Each one was given in terms of weight. Calculate her final grade as a student. Calculate the final grade of a student with an exam score of 94 and the project of 89 and homework of 83. So the first thing is I can do this in 2 ways. All right. So what was our exam score? The final grade. The final grade for exam was 94. Then 89 for project. Then 83 for what? For a homework, yeah. So what you do is you calculate the weight and the actual values that you have. So 50 times 94, 35 times 89, 15 times what? 83. Then you sum up these figures here, the weight percentage. So the total here you're getting will be 100. So 50 times 94 plus 35 times 9 plus 15 times that over these figures here, 50 plus 35 plus 15, which is 100. And divide that in there, you're going to get what? 90.6. That was the final score of the student. So this question, I think, was even there in the exam. If not in this, the previous exam paper, because yeah, it is here. Is it? No. Should be in the previous paper, yeah. Anyway, it was there in the previous paper. So this is what you're supposed to do. I repeat, we're given the weight of the exam to say exam carries 50%. All right, then project carries 34%. Then our homework carries 15 as a weight in percentage. And what she actually got in the exam was 94. In the project, she got 80 what? 89. And the homework she got 83. So you can do this in 2 ways, okay? So you can just do 50 over 100 times 94 to find the actual score for exam. Then 35 over 100 times 89, you get the figure that you got. And 15 over 100 times 83, you get the figure. Then when you total these ones, you get the exam score. This figure here may vary, it may not always be 100. Maybe it can even be 8, but you need to know that these are the weights. You get the proportions times what you actually got, and you total them up. Or use what the given Bible did, just multiply this one times that, this one times that, this one times that, divided by the total of the weights there. You get 90.6. Another common question which came in one of the tests, we are told that the company has 4 locations at which customers were surveyed. So we have these ratings here. We are being asked to calculate the total average. So the locations 1 to 4, don't use this number. These are just locations. They can be A, B, C. So the average weight. So what you do is on the average ratings or the weight, you're going to multiply this one times that, 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 over the total N. All right. So dealing with the total here. So when you total up here, you're going to get 361. So you multiply that and that and that, and you add the number of customers, because we're looking at the average number of ratings for the customer. So it's usually the opposite here. If they tell you calculate the total average customer rating, so you get the total for this part here. If they told you the total average number of customers, you get the total of the ratings to be down on the total here. All right, so here people get confused. The get confusion is which total do we get? Total here or the total there? So here we're asked to calculate the total average customer ratings for the customer, for the company. So don't get the total of the average ratings. Same here. Calculate the what? Calculate the final grade of the student. All right, so here this is a final. Don't get the final results total here, no. You get of the other of the weights. So I got 100. They ask you the final weight, that's when you do the opposite. That's how I can simplify it for you. So here, calculate the average customer ratings. So don't get the total on the ratings, get the total on the customers. 361. So multiply this by that, this by that, this by that. The total here you divide by 361. So we get 7.6 as our average customer ratings for all the 4 locations. So that's what you do. Average means mean. Average means mean. This question has never come. So if it's going to change on topics, take note of this one here. These two, I've seen them before. So you are the third intake he's taking. So he's limited with the number of questions. So they're hovering around there. Okay. So I think I will. So we're given the following. The table below lists grades and credit hours and in one semester by a college student, assuming A, B, C, in grades corresponding. A is what? 4. Meaning B, A is 4, meaning B is what? 3. And C is what? 2. So calculate the average grade point. So calculate the student's grade point average for the semester. So we're looking at the grade average. Calculate the student's grade point average for the semester. So whenever you hear that talking about this point, don't get the total for this guy. If they're asking calculate the credit hours, don't get the total for what it's being asked. So since I've mentioned this grade point average, don't total up here, total up here. So this is 6, 10, 14. Get the total there. Then just multiply these figures. 3 times 4 plus 3 times 2 plus 4 times 4 plus 4 times 3 divided by 14. So you divide by 3 plus 3 plus 4 plus 4. So you're dividing by the credit hours there. So this is 4 times 4, 3 times 2, 4 times 4, 4 times 2 divided by 3 plus 3 plus 4 plus 4. So you're getting the total for the credit hours there. So this is what is going to give you the student average point grade, which is 3.29. All right, so we end here for now. We end here for now. I'll send you homework based on what we have done. Have a great day and keep studying. Thank you so much. And enjoy the rest of the day. Unless there's any question that is burning, you could ask.
Mr. Collins,
Yes.
I wanted to find out someone had. I've seen other people talking about the QM Bible. Is this the one that you're using?
Yes.
And could you please?
All right. I will share it.
All right, thank you.
It's me. If I haven't sent it, or I'll send on the paid up group.